All right, first thing, let's go over last night's homework. So we'll go over last night's homework. What do we got? What do we got? What do we got? Assignments. So what was last night's homework? 5.2. Well, any questions on them? It was all easy. Okay. See, good. See how easy algebra 2b is? Okay, today's lesson. Not so easy. Now what we have to do, now you guys know what a rational function is. Now you guys have to learn how to graph them. Okay, so let's start with an easy one. Something like that. See how you have a polynomial over a polynomial? That's a rational function. Now, whenever you graph rational functions, if you just go through the 4 steps I'm going to show you, it's pretty easy. Okay, now the 4 steps. You plot the X-intercepts, the Y-intercept, the vertical asymptote, and then the horizontal asymptote, and then after that, you should be able to draw the graph. Okay, so let's go through these things. I think you did these last night anyway. How do you find the X-intercept? What should I look for? How do you find the X-intercept of any graph? You set y equal to 0, right?
Yeah.
So if a fraction is equal to 0, does that mean the top is 0 or the bottom is 0? The top. So you just look at the top. What makes the top 0? Negative half. So anytime you want to find the X-intercept, you look at the numerator. What makes the numerator 0? That's your X-intercept. How do you find the Y-intercept? You substitute 0 for x. So if I plug in 0 for x here and here, basically you just get that, right? What is 1 divided by negative 1? Negative 1. This is easy. Vertical asymptote. To figure out where you have a vertical asymptote, you look at the denominator. What makes the denominator 0? 1. So the vertical asymptote is x equals 1. Remember, a vertical line is x equals a number, right? So you can't just say 1, because every year students want to just say 1. No, it's x equal 1. Because if you just say 1, that doesn't mean anything. You have to give an equation of a line. Now the horizontal asymptote is a little tougher to figure out. See, that way everybody had a chance to get it. Because if I just walked straight over there, then the people here didn't have a chance. Right? But if I walked around, then you had a chance. Now, the horizontal asymptote, this is the one every year people have a hard time with. But it's not that hard. All you gotta do is look at the degree of the top and the bottom. Okay? So if the degree of the top and the bottom are the same, which they are, right? You guys know what the degree is, right? The highest power. If the highest power are the same on the top and the bottom, then you just look at the coefficients, 2 over 1. So the horizontal asymptote is y equal 2. So here, let me try to, I'm sure they say this in the book. So if you have a function that looks like this, ax to the n plus dot dot dot, plus, this is the first term, like if you multiplied out everything, and bx to the m plus all the other terms, then, if n is equal to m, if the power on the top and the bottom are the same, then the horizontal asymptote is y equal a over b. You just look at the leading coefficients. That's all you gotta do. It's simple. What would happen if the degree of the bottom is bigger than the top? What if m is bigger than n? Then the horizontal asymptote is y equals 0. And if the power on the top is bigger than the bottom, like that, then there is no horizontal asymptote. But in this class, you don't have to worry about that, because if the power on the top is bigger than the bottom, then we have these other kinds of asymptotes. We have oblique asymptotes. Remember I was telling you about that? But in this class, we're not going to do that. So you don't have to worry. You just have to worry about horizontal asymptotes. Okay, so does everybody understand why y equals 0 is the horizontal asymptote? Because when the degree of the top and the bottom are the same, you look at the coefficients, 2 over 1. It's 2. So y equals 2. Now, once you figure out these four things, you put them on the graph. Now, after a while, you don't even have to write this out. You just automatically do it. Like, okay, x-intercept, -half. Y-intercept, -1. Vertical asymptote, x equal 1. Horizontal asymptote, y equal 2. 1, 2. Okay? So, put these four things on the graph. Now, you just gotta have some common sense over here. Okay? Now, whenever you have, like, here's a horizontal asymptote, here's a vertical asymptote. Whenever they're crossing, either the graph is gonna be up here like this, or it's gonna be down here like this. Which one do you think it is? Do you think it's up here or down here? Yeah, you know why it's down here? Why? Because you gotta pass through these 2 points. If you plot points, that means the graph gotta go through them, right? So it's like this. And how do asymptotes work? They get closer and closer without touching, yeah? Like that. So as the graph is going up to the left, see how this graph is getting closer and closer to it, but it doesn't touch it. And then over here, it's getting closer and closer, but it doesn't touch. Now, on the right side of this vertical asymptote, see how, again, they're crossing? Either the graph is going to be up here, or it's going to be down there. Which one do you think it is? Yeah, it's going to be up on the top. Why? This is the correct one. Why is it up there? How come it's not down here? Because if it were down here, wouldn't you have to cross the x-axis? But see, there's no x-intercept. This is the only time the graph crosses the x-axis. Now, every year, students go, well, can't you just go around the x-axis like that? No, how come you can't go around the x-axis? Because the x-axis goes on forever. You can't go around it. Anyway, if you could, this is not even a function, right? You guys remember what a function is? A function has to pass the vertical line test. Remember that? Every vertical line you draw can intersect the graph at most once. So this wouldn't even be a function. No, you cannot. So that's why the graph has to be up there. And there you go. That's what a typical rational function looks like. And I want you to notice something. Whatever your horizontal asymptote is, as the graph goes out to the right and the left, see how it's getting closer to it? So just remember the pterodactyl like this. When the graph goes out to the left and the right, the graph gets closer and closer to the horizontal asymptote. So if you have a horizontal asymptote there and your graph is not getting closer and closer to it, you did something wrong. Okay, this is an example of an easy one. Are you ready to kick it up a notch? All right. Y equal 2x squared minus x minus 1 all over x squared minus 9. Yeah. Yeah. So what do you do here? What's the first thing I should do? You should factor everything. Now I don't know what form the book gives it in. Maybe the book gives it in factor form already, but if it's not, you need to factor it. So the top can be factored what? 2x and x, 1 and 1, minus plus. Did I do that correctly? Of course, I'm the teacher. And the bottom is x plus 3 times x minus 3, right? Okay, now once you have it all factored like that, now we are ready to graph. Now, just do these 4 things and it should be easy. So, I'm not going to write them anymore. We're just going to put them on the graph. Because this is how we do it in calculus, okay? X-intercept. How do I find the x-intercept? What do I look at for the x-intercept? The numerator or the denominator? Where is the numerator 0? Negative half and 1. So there's 2 x-intercepts here. Negative half and 1. Y-intercept. How do you find the y-intercept? You plug in 0 for x, right? Now, a lot of people would go over here and do it like if I plug in 0 for x, you're going to get 1 times -1 all over 3 times -3, and you get?
Or 1/9.
1/9. But you know what's easier for me? Just do this. Look at this one instead, look. If I plug in 0 for x, you get -1 over -9. You get 1/9. It doesn't matter. Whatever you do, you'll get 1/9. It's like right there. Okay, now what about the vertical asymptotes? What are the vertical asymptotes? You look at the denominator. What makes the denominator 0? Plus or minus 3. So your vertical asymptotes are going to be x equal -3 and x equals 3. Now, if you want to just list them like I did over here, you can, but I'm trying to teach you the most efficient way. And then now the horizontal asymptote. If the power on the top and the bottom are the same, which they are, you look at the leading coefficients, which are 2 over 1. What is 2 over 1? 2. So y equals 2 is the horizontal asymptote. Okay, here we go. Now, on the left side of this vertical asymptote, there's only two things the graph can do. It's either going to be here like this, it's up here, or is it going to be down here? Which one do you think it is? It's got to be up here. How come? How come it can't be down here? Yeah, because there's no x-intercept there. See, that's why it's easy to figure out. Okay, now, on the other side of this vertical asymptote, either the graph is going to start up here. See, when you have a vertical asymptote, see how the graph either explodes downward or the thing shoots upward like that, right? So, on this side of the vertical asymptote, do you think the graph is going to be shooting up like that or shooting down like that? What do you think? Use your common sense here. Yes, it's going to be shooting downward. How come?
Oh, it has to go through the points. Without passing the...
Yeah, but then, like if it was up here, I could hit this point, I could bounce off and then go to that point, right? Whereas if the thing is down here, it would have to go through that point to the y-intercept. How come y doesn't have to go through this point? We just learned this last.
Or the degrees.
Because this x-intercept came from which factor? -½ came from this factor, odd power, so the thing is going to go through. Oh, so it's just like polynomial functions, Mr. Park. Yeah, exactly. So in the numerator, if you have an odd power, that means for that x-intercept, the graph is going to go through. See, that's why this thing is down here, because it has to go through the x-intercept to hit the y-intercept. I'm going to give you another tool to help you later too. Okay, now, I'm coming up to this other x-intercept. Do I go through it or bounce off? I just told you. You go through it. How come? Because there's an odd power on that factor. The factors tell you whether to go through or bounce off. And then now what? What do I do now? You have to be, either the graph is going to shoot down or shoot up. It can't shoot up because there's no x-intercept there, so it's got to go down. Now, on the right side of this vertical asymptote, you got two choices. The graph is either up here or down there. Which one do you think it is? Yeah, it's up here. That's because if it was down here, it would go through the x-axis. But there's no x-intercept there. So that's what the graph looks like. Now I'm going to give you something else to help you even more. You see these factors in the denominator? What do these denominator factors tell you? The vertical asymptotes, right? If you have an odd power on those factors, that means on the vertical asymptote, if one shoots up one way, the other one's going to shoot down the other way. So if you have an odd power, they just go opposite ways like this. But if you had an even power on the denominator, they would both go like this. Either go both up or both down. You guys get it? So in the denominator, odd power means they would go opposite way like that. Even power means they'll go the same way, either both up or both down. Whereas in the numerator, what do the powers tell you? Because the numerator tells you the x-intercepts, right? So, what do the powers tell you? If it's odd, it goes through. If it's even, it bounces off. So, there's so many clues to help you graph rational functions. Okay, I'm gonna do another one that has a lot of powers in it so you guys can see the difference between the two. See how this is a little more difficult than last night's homework, huh? Okay, y equal x plus 1, x minus 2, all over x minus 1, x plus 2, but let's put some powers. Let's put a 2 on this one and a 2 on that one. See, because you gotta know the difference between odd and even powers, just like polynomial functions. So again, everything we draw is freehand. Okay, go through the 4 things I taught you. X-intercept. You know what? You guys want to write it out? Here, let's just, what the heck, let's just do it. X-intercept. Y-intercept. Every single problem tonight, because every single problem of tonight's homework, you just graph it. That's all it is, graph, graph, graph. Vertical asymptote, horizontal asymptote. Okay, how do I find x-intercepts? You look at the numerator. Now, notice that I factored it for you, so you don't have to factor it. So it makes the problem a lot easier. So, you look at the numerator, what makes the top 0? Negative 1 and, so I got 2 x-intercepts. Y-intercept, you plug in 0 for x. If I plug in 0 for x, what are you going to get? 1 times 4 all over 1 times 2. Did I do that correctly? Yes, I'm the teacher! 2. The y-intercept is 2. Vertical asymptote. That's when the denominator is 0. What makes the denominator 0? 1 and negative 2. So you don't write 1 and negative 2. What do I write? X equals 1. X equals negative 2. Because an asymptote is a line, that's why. You have to give an equation of a line. Now horizontal asymptote. You have to compare the powers on the top and the bottom. If I were to multiply out the top, what would the first term be? If I multiplied out the top?
1x cubed.
Wouldn't it be 1x cubed plus all the other stuff? If I multiplied out the bottom, what would it be, the first term? 1x cubed plus all the other stuff. So is the degree at the top and the bottom the same? Yeah, so then you just look at the coefficients, 1 over 1. So it's 1, y equals 1. Okay, that's the 4 things. That's all you gotta do. Now you put them on the graph. X-intercept is negative 1, 2. Y-intercept is 2. Vertical asymptote, x equal 1, x equal negative 2. Horizontal asymptote, y equal 1. Now, if that's the only thing you can do, at least if this problem is worth 8 points on the test, I give you 2 points right there. No, I changed my mind. I give you 1 point right there. You gotta draw the graph. Okay, let's start on the left. Here's the vertical asymptote. Now, to the left of the vertical asymptote, there's only 2 things the graph can do. Either it's gonna go up like this, it's gonna go down like that. Which one do you think it is? Since there's no x-intercept here, that means the graph cannot cross the x-axis. Gotta be up here! Because if you drew it down here, it would cross the x-axis, but there's no x-intercept. Anyway, if you really don't know, let's just pretend you don't know. You really don't know, what could you do? Plot a point, exactly. Like, if this is negative 2, like, plug in negative 3 and see what you would get. But you can get something up here. So that you can. But that's just last resort. You don't want to. So, this graph is exploding up here, shooting up like that. So on the opposite side, is it going to be shooting up also? Or is it going to be shooting down there? Which one is it? How do you tell? What did I just teach you 2 minutes ago? This vertical asymptote is at negative 2. Didn't it come from this factor right here? Odd or even power? Odd. So what did we say about that? It's going to go opposite way. No. Asymptotes tell you whether to go opposite way or same way. So it's going to be opposite way, so it's going to be down here. Now I'm coming up to this x-intercept. Do I go through it or do I bounce off? Well, look, this is negative 1. Negative 1 came from this factor. It has an odd power. So bounce off or go through? You go through. Anyway, if you didn't go through, if you bounced off, then the y-intercept should be here somewhere, but the y-intercept is up there, right? So you got to get to it. You got to go through. Now, some of you are going, wait a minute, Mr. Park. This graph is crossing the horizontal asymptote. Can a graph cross the horizontal asymptote? Yes, well, it just did. Yes, you can cross a horizontal asymptote. You cannot cross a vertical asymptote though. Because horizontal asymptotes only take effect out here. Remember the pterodactyl? Ah! Only as the graph goes out to the left and the right, then the graph starts getting closer and closer to it. So yes, you can cross a horizontal asymptote. Anyway, duh, I just did it here anyway. And then, whoosh. Mr. Park, how come the thing can go down and shoot downward? Because then it would cross the x-axis, but there's no x-intercept there, so that's why it has to go up. Now, some of you are probably noticing, hey, Mr. Park, when you get two vertical asymptotes, there's only four things the graph can do, right? It's either going to be a u up, a u down, a slide down, or a slide up, right? That's the only four things it can do. Yeah, so in this particular case it's sliding up like that. Now, on this side of the vertical asymptote, see how it's shooting up? So on the opposite side, is it going to be shooting up also, or shooting down? Well, instead of guessing, this is 1. Isn't this 1 right here? What factor did this come from? That one right there. It has an even power. So if you have an even power in the denominator, that means they go the same way. So if this one's shooting up, then on the opposite side, it's got to be shooting up too. Okay, I'm coming down. Yeah, but Mr. Park, you're going to cross the horizontal asymptote again. Is that going to bother you? No, because... Okay, now I'm coming up to this point. What do? Do I go through it or bounce off? Okay, now when you bounce off, how come? Because this is 2. 2 came from this factor here, the even power, bounce off. And then now I bounced off Mr. Park. What do? Pterodactyl. Look. So if you draw in a horizontal asymptote, when the graph goes out to the right and the left, like your graph better be getting closer and closer to it. And it is. So if you can understand what I just did right here, then you understand everything for this chapter. Or for this section. You guys get it? You see the difference between odd and even powers in the numerator? In the numerator, that tells you whether to go through or bounce off the x-intercept. In the denominator, it tells you what happens by the vertical asymptote. Either they go opposite way if it's odd power, or the same way if it's even power. Okay, one more example and we're done. Okay, let me think. X squared minus x minus 2 all over x squared. No. We gotta do 2 more examples. Because we never did one like this. How about this? X minus 1 over x squared minus 4. Okay, let's do this. No, I changed my mind. I want to put the 4 on the top. 4, 1. I like that better. I changed my mind. I want a 2. I'm sorry. Okay, here we go. Let's go through the 4 steps. Okay, again, I'm not going to write this. We're just going to put it right on the graph. X-intercept. You guys should know what to do already. Where do I look? Numerator. What makes the numerator 0? 2. Y-intercept. Plug in 0 for x. You get 2. Vertical asymptotes. Now, we forgot to factor it before we started. Here we go. Factor. What makes the denominator 0? 1 and negative 1. So x equals negative 1, x equals 1. And then the horizontal asymptote. Well, what happens when the power on the bottom, see, is bigger than the top? See, the top power is 1, the bottom power is 2. What does, I wrote it, I erased it. It was there, plus it's in the book. What does it say? No. Y equals 0. The x-axis is a horizontal asymptote. It's like that. But then you really don't have to put that there because you already have it there, but that's okay, we'll put it in anyway. Now, does it bother you that this point is right on the horizontal asymptote? No, it shouldn't bother you because look, over here, the thing touched it twice. Because horizontal asymptotes only take effect down here, like that. So when you're near here, don't be surprised if it crosses the horizontal asymptote. Only as you go out to the left and the right, then it starts grabbing. Okay, now, we're over here. Now this one, there's really no clue. Should I go up or should I go down? Which one is it?
Down.
How do you know? 50-50 chance. Come on, somebody come up with something good. That's because over here, do you see this Y-intercept? How do I know in between these two vertical asymptotes it has to go U up like that? How come it can't slide down? Because there's no X-intercept, that's right. You can't cross the X-axis. So there's no sliding, it's either U up or U down, but how can it be U down if the Y-intercept is up there? So that's why it's going to be U up. Because if you made the U down, it would cross the X-axis again, but there's no X-intercept. And since on this side the thing is exploding upward, then on the opposite side, it's got to be exploding down. Why? Because this vertical asymptote came from this factor. It has an odd power, so that means it goes opposite ways like that. So, anyway, if you just don't know, plug in a number. What's a number smaller than -1? -2. So plug in -2, plot that point, and you can see whether it's above or below. But I'm trying to do this without plotting too many points. We just want a quick sketch, that's why. Now, on this side of the vertical asymptote, see how the graph is shooting upward like that? So on the opposite side, is it shooting upward or shooting downward? Very good, down. Why? Because this is 1, right? 1 came from this factor, odd power, which means they go opposite way. So if it's up on one side, it'll be down on the other, like this. Okay, now I'm coming up to this X-intercept. Do I go through it or bounce off? How do you know? Very good, odd power, because 2 came from this factor, odd power. Go through, so go through, and then every year, there's always students that just do this. No, what did I just teach you? If there's a horizontal asymptote, what has to happen? Like this. As the graph goes out to the left and the right, you gotta get closer and closer to it. So, if you have a horizontal asymptote there on your graph, and your graph is not getting closer to it on the left and the right, big points are coming up. Because then you're just not understanding how the horizontal asymptote works. Okay, last example and we're done. Woo! Okay, here's an interesting one. Y equal x squared minus x minus 2 all over x squared minus 1. Okay, what's the first thing I should do here? Rhymes with factor. You should the first thing you should do, if it's not already in factored form, is put it in factored form. X minus 1, x plus 1. Now, before I go on to the next step, does anybody notice anything? You can cancel. This cancels this, and all you're left with is just x minus 2 over x minus 1. So if you can cancel something, you cancel it. Because then it's way easier to graph this, right? This actually makes the problem easier. Except there's going to be a little twist at the end. So you don't even look at this, you just look at this now. Can I graph that? Yeah, that's pretty easy, Mr. Park. I'm just going to do the 4 things you taught me. X-intercept. 2. Very good. You guys are on it. Y-intercept. 2. You plug in 0 for x, right? Let's get -2 over -1. Vertical asymptote. X equals 1. See, we can do it without the training wheels. And then horizontal asymptote. If the degree of the top and the bottom are the same, which they are, you look at the coefficients, which are 1 over 1. So y equals 1 is the horizontal asymptote. And then, so on this side of the vertical asymptote, see how you have a vertical and a horizontal? Either the graph goes or it goes. Yeah, it's this one. How come it's this one? Because the y-intercept is there. If you drew it down there, look, no more x or y-intercept there. No cap. And then look, the thing is exploding up on this side. So on the opposite side, what? Going to explode up or explode down? How come?
There's a point.
No. Well, you could go down like this to get to it. Right? The reason is the odd power. 1 came from this factor here, look, odd power. That means they're gonna go like this, opposite way of the vertical. Remember, the denominator tells you what happens on the vertical asymptote. The numerator tells you what happens on the x-intercepts. So, now do I go through or bounce off? How come I'm going through? There you go, odd power. Right there. This is the x-intercept, odd power. That's why I went through. And then, yeah, but I don't know what to do now. Pterodactyl. That's all you gotta remember. It's so easy. Pterodactyl. So box that, that's the answer. No. If you did this, that's a -2. That's because we canceled out a factor. If you cancel out, look at the original, this is the original problem right here, right? What is the domain? This is why you did last night's homework. What is the domain? Any number except 1 or -1. Because anytime the denominator is 0, it's undefined. So that means this graph is undefined at 1 and -1. Well, at 1, it's undefined because there's a vertical asymptote. But at -1, Mr. Park. Yeah, so what you have to do is, and can you guess? You put up. Did you guys do this before? Oh, it's not called an open circle. Some people call it open circle, some people call it a hole, some people call it a puka. No, the official mathematical name for that point right there is called, anybody? It's in your book. It's called a removable discontinuity. Now, if you want to call it a puka hole or open circle, you can, but you go to college, you can be laughed out of the dormitories. Okay? This is the correct name, removable discontinuity. Because if you come to calculus, that's what we call it. Because that's the official name. And what are the coordinates of this removable discontinuity? -1 comma something. How do I figure out what the y-coordinate is? Yeah, you plug it into which one though? Should I plug it into this one or that one? No, because if you plug it into this one, you're going to get 0 over 0. That's undefined. You have to plug it into this one. If you plug it into this one, -1 minus 2 is -3. -1 minus 1 is -2, and that comes out to. So, our picture is a little bit off, so I'm going to change it because you want to make it accurate. So the removable discontinuity should be a little bit lower right there. There you go. Bam! Now you got full credit on this graph. Oh, so Mr. Park, every time I cancel out a factor like that, there's going to be a removable discontinuity again. A puka. Maybe. You have to completely cancel out the factor. That's the thing. Okay, so if you could just remember what I just taught you here, tonight's homework, easy. Oh, by the way, we have a quiz on Monday. Okay, let me just tell you what's on the quiz. Get this on the video too. Because I didn't make a practice quiz. All it is 6 graphs. That's all it is. Okay, the first 4 problems are just graph a polynomial like this. Okay, let me give you something. -2, x minus 1. So you have to know the difference between first, second, and third power, just like we did on the homework. X plus 2, x minus 3. So why don't I put 2, 1, no, move spread. 3, 2, 1. Okay, there. Okay. You're gonna have 4 just like this. Okay, so what's the fastest way of graphing this? Plot the x-intercepts, which are 1, -2, and 3, right? Now what? Come on, you guys have been doing this for homework the last 2 nights. The y-intercept. How do you find the y-intercept? You plug in 0 for x. So if you plug in 0 for x, you're going to get -2 times 0 minus 1 cubed, 0 plus 2 squared, 0 minus 3. Multiply that together, what have you got? Is this the hardest part of the problem? -24. So here, just change the scaling right there. And if I were to multiply out everything, what would be the very first term? -2x to the 6, right? Just add up all the exponents. Okay, so even degree, so it's either both up or both down, right? But since the leading coefficient is negative what? Both down, so it's gonna be like this. It's gonna be like this, and like that, the end behavior. And then now all you have to remember is, do I go through or do I bounce off? Okay, so, I'm coming up to -2 here, go through or bounce off, so you should be looking up here. -2 came from that factor, even power, so the thing bounces off. And then somewhere halfway in between, I'm gonna hit the minimum point, then I'm gonna go through the x-intercept. Now I'm coming up to this one, go through or bounce off. 1 came from this factor, odd power, but you have to know the difference between first power and third power. So yes, I'm going through, but what? You gotta flatten it out. Just, as long as you just do it a little bit, that's good enough for me. But you just don't go make it straight through. And then now what? Go through or bounce off this one. 3 came from this one, odd power, so straight through, right? Because first power. And then, see, look, that behavior right there. Perfect. So do you see the difference between first power here and third power? Third power to flatten out. Okay, and then the other two problems are, you know those base graphs we went over? You have to do stuff to the graph. Remember these two graphs? Remember you did it on the homework? What's this one? What does this one look like? What were the 2 key points I told you to remember? 1, 1, and -1, -1. So it looks like this here. And then what about this one? What does this one look like? 1, 1, and -1, 1. So it looks like this. So I'm going to give you 2 graphs, one with this one, one with, so like y equals, just make up something, 1 over x plus 2 minus 3. So if I know what this graph looks like, how do I graph this one? You shift it 2 to the left and 3 down. So just take this and move it 2 left and 3 down. You guys can do it, right? So here, to me, this is the easiest way to do it. See how right here, this is where the vertical and the horizontal asymptote cross? So you're at the origin, go 2 left, 3 down, put that point there, draw in your asymptotes like this, and then now easy, just go 1, 1, and then -1, -1, and then easy. And then what about for this one? Y equal -1 over x minus 2 squared plus 1. First of all, what does that negative do? Reflect over the x. So instead of both of them up, it means it'll be both of them going down like that then, right? So again, do the same thing. This one is shifted 2 to the right and 1 up. So if I go 2 to the right and 1 up, I'm going to be right there. That's where your asymptotes are. And then, since they're going to be both down, you just go 1, 1, 1, 1, and then like that. That's why you don't need practice quiz for this. I expect everybody to get 20s, unless you don't. All right, so we got that on video. So, how much time do we have left? 15 minutes? You know what? You can actually finish your homework before you leave today. You know? That's not going to happen, Mr. Park. It's Friday. So for you guys got to remember there's a quiz on Monday.